Hello everybody and welcome to Conics 4. In this tutorial we will take some time to have a look at some common problems and solutions that you will come across as you progress through different questions in Conics. In Conics 3 we were looking at the ellipse, and when we had the minor and major axis we needed to find those two very important points which were called the focal points. And what we did to find them was we measured off half the major axis, then we got our compass with that distance set on it, moved it to point A, the top of the minor axis, and we swung an arc. Now where that arc cuts the major axis will get you the two focal points. And a key point of that learning was that half the major axis is equal to the top of the minor axis to the focal points. It's the same thing. We had a look there at how we went last week of finding the focal points. Well, it's often a thing when you're doing ellipses that they will give you a certain piece of information and you have to figure something else out. So in this partially drawn setup of an ellipse, up here we have the major axis and we have the focal points, but we don't have the minor axis. So we're going to look at how we're going to go about finding the minor. Then we're going to move on and we're going to have the opposite to this. We'll have the minor and the focal points, but we won't have the major. After that, we're going to talk about this piece of theory, which is the distance between Now, so we'll start off here, as we said, with the first question up here. So here we have the major axis, but we don't know the minor. So what do? We do the opposite of what we did last week. I will get half the major, like so, put it on the focal point, either one will do, and I'll swing an arc. That will give me the bottom and top of the minor axis. So when you're doing these questions, it's never a case that they'll just give you all the information and you do A, then you do B, then you do C. Sometimes they'll get you to work backwards, okay, to really kind of develop your thinking. In the second one here, I have the minor axis, okay, and we have the focal points, but we don't have the major axis. So what am I going to do this time? Well, I know that crucial piece of information, that the distance from the focal point to the top of the minor axis is the same as half the major. So put your compass down here, swing an arc there, swing an arc there, and this will find me the end points of the major axis on that specific ellipse. Now we'll just park them up for now, and we'll come back to them later on. Now what I want to look at is what we mentioned when we're looking at the setup of the sheet, which is when you have two circles in contact, the distance between the two circles is the radii added. So I just drew this radius 20 and radius 25. So that means the distance from here to here is 45 millimeters. Okay. So another crucial piece of theory. Down here in the bottom, I have a circle. Now, it is a possibility that in a short question you could just be given a circle and you would be told find the center of that circle. Well, what you would do is you would draw two chords anywhere. So I'll draw one chord here and I'll draw another chord over here. Now we'll go and we'll bisect them with our compass. So just eye it up that you're a little bit over halfway. Draw an arc one side, keep the same radius, and draw an arc the other side. Now I'll do the same with this chord. Make it a bit bigger. swing an arc from this side, and swing an arc from that side. Now we'll draw in the bisectors, and the center of this circle must be on the exact point where the two bisectors cross. Why do we look at these issues? We look at these issues because when we come across questions like this is a fairly easy question to draw if you know how to do so and you know your theory. But you will have to apply your theory. You will have no problem finding that point there, and you will draw a light circle in here, radius 25. You would also have to draw part of a light circle there, radius 25 as well. But how do you find this point? Well, this is where you use your theory. I would know to set my compass from here to radius 50. Why? Because the center between the two circles in contact is the radii added. So set your compass to 50 and I would swing an arc down along here. Then I will come over to this point. This is a known point. Okay, it's 31 mil out from the edge. I'd set my compass to 25 millimeters and I would swing a second arc. Where the two arcs would cross would find you this point. And that works because from any point on a circumference to the center is the radius. But we'll come back to that in another question. So we'll go on now with the drawings. Okay, and there it is. That's the center of that circle. Now just before I leave this, to go back to this guy here, we said when you have two circles in contact, the distance between them is this radius added on to that radius. That is very clear to see. Sometimes though, you could have a circle. I'll just draw in a line here, anywhere at all. And you could have a smaller circle inside that. So I'm going to get my compass and I'm going to set it to radius 10. Now it doesn't matter what you set it to, just set it to something fairly small. Because what I want to do here is I want to draw a small little circle on the inside here. Now, this is radius 10. This circle here, the bigger one, was radius 35. So I know from here to any point on the curve it's radius 35. Therefore, if it's 35 from here to here, and this small circle is 10 millimeters, well, that means from here to here is 25. 35 minus 10 would be 25. Okay, so that's another piece of information for you to bear in mind and think about. Now, the last two things I want to do with this is putting on a tangential arc onto this, and then down here I'm going to put a tangential arc in between these two circles. Okay, so we'll do this one first. Now, the tangential arc that I'm going to want to put onto this here is going to be 100 millimeters, okay? It's on the worksheet that is in your OneNote, okay? So it's 100 millimeters. So, what will this really be like? It's like having two smaller circles inside a big circle, okay? Now, this guy was radius 30, and this guy is radius 16. So, as we saw over here, the distance is the smaller radii subtracted from the bigger one. Okay, that is the distance between the 2 points. Okay, so what we'll do is we'll subtract 30 millimeters from 100. And that would leave me with 70, of course. So from here, I'm going to swing an arc, radius 70. 16 from 100 is 84. So we'll set our compass to that. And that is the point now where I'm going to set my compass to 100. And I would be able to draw in a tangential arc to encompass both of these perfectly. Okay, and that goes back to this piece of theory, which is that when you have a small circle enclosed in a big circle, you subtract the small radius from the big radius. Okay, and it's the exact same thing there. Now the last one, what we want to do is we want to put on an internal arc here, tangential. So it's going to be radius 80 millimeters, and it's going to be touching this guy here, and it's going to be touching around here. So we're actually going to have a bit of this theory and this theory mixed up in this one, because this circle is going to be on the outside, okay, and this guy is going to be on the inside, similar to over here. So let's look at this guy first. If I have a big circle, or part of it, touching this guy, it's going to be the radii added. So I add 30 to 80, and I swing an arc of 110 millimeters. This guy, when I draw it though, is going to be on the inside, okay? So I'm going to subtract 16 from 80. So I'll set my compass to 64. Let's double check that. And that now is the point I'm looking for. So I can set my compass now to 80. Put it down there. And I'll be able to draw in that tangential arc. Okay. So that works because this guy is on the inside, so we must subtract it. And this guy was on the outside, so we had to add it. Okay. So I'll just put the figures on them. So from here, you're swinging an arc of 110. And that's because it's 80 plus 30. Over here, we're swinging an arc of 64. And that's 80 minus 16. Okay. So you need to think about those, folks. You need to think about why they're working. Okay. Because you need to get a true understanding of this so that you, in the future questions, will be able to apply this theory and problem solving methods to your questions to have successful outcomes. So that's it, folks. More videos to come. Take care. Stay safe.